Hi everyone, this is Surya Phani. Currently, I'm a PhD student at IIT Kanpur. So today we will discuss a new topic, previous year questions for JEE Main. So topic is wave optics. So now going into the first question. So the first question. So what is the first question? The Brewster's angle IB for an interface should be. So what is the Brewster's angle? So according to Brewster's law, when the beam of a polarized light is reflected from a transparent medium to refractive index mu2. Okay. Suppose a beam of unpolarized light is reflected from unpolarized light, a beam of unpolarized light, unpolarized light is reflected from transparent medium of a refractive index mu2 and reflected like completely polarized at a certain angle of coincidence is called the angle of polarization IB. Okay. So according to Brewster's law, okay, according to the Brewster's law, there is a unpolarized light will be there, right? There will be unpolarized light incident on a surface of a transparent medium at a specific angle. Angle of incidence is called the polarizing angle IB. Okay, so the reflected ray becomes a completely polarized. So then what this is the law. What will happen? Tan IB is equal to, here they are given mu2 by mu1. So for air we know it will be mu1 is equal to 1. So tan IB is equal to mu2. So it is, if it is greater than 1. So how we are saying it is greater than 1? So it is going from a transparent medium of refractive index mu2. So transparent medium. So mu2 should be greater than 1. So tan IB should be greater than 1. So definitely tan 45 degrees is equal to 1. So IB should be greater than 45 degrees and less than 90 degrees, right? So option B is the right answer. So going to the second question. The angular width of a central maximum in a Fraunhofer diffraction. So they have given the angular width of a Fraunhofer diffraction of a lambda 6000 angstroms. Okay, is theta naught. Okay, it is the angular width of a central maximum. Angular width of a central maximum. Central maximum. So when the slave slit is illuminated by another chromatic light. Okay, the slave slit is illuminated by another chromatic light. Angular width decreases by now the angular width decreases by, so angular width decreases by 30% when same slit in another. Suppose if you use another monochromatic light. So the what is the wavelength of that another chromatic light? So the relation is theta. How the theta is related with 2 lambda by A, right? So if theta, initially we had theta naught is 2 into 6000 angstroms divided by A. Now it is theta 1. Okay, we will take theta 1. It is 2 into some lambda. We don't know, some lambda 1 divided by A. So theta 1 is decreased by 30%. So theta, initially theta 30% decrease means minus 0.3 naught, right? Of theta naught. So minus 0.3 theta naught. So new theta 1 will be 0.7 times of theta naught. It decreased to 30%. So new theta will be theta 1 will be 0.7 theta naught. So if we divide theta 1 by theta naught, we will get 2 lambda 1. So 2 cancel lambda. We will get the lambda 1 divided by 6000 angstroms. So we know theta 1 by theta naught will be 0.7. So 0.7 into 6000 angstroms lambda 1. So it will be 4.2 into 10 cube angstroms. It is 4200 angstroms. So option C is the right answer. So going to the next question. The angular resolution of, they are given angular resolution of a 10 centimeter diameter telescope. There is a telescope, okay? So diameter is 10 centimeter of a telescope. Telescope diameter. Telescope diameter. Means at a wavelength of, they have given the wavelength of 5000 angstroms, right? So they are asking the angular resolution. The angular resolution is delta phi is equal to 1.22 lambda by d. So it will be 1.22 lambda. We have to convert now. So 500 angstrom is 500 into 10 power minus 10 meter. 10 centimeters means 10 into 10 power minus 2 meter. So if you solve this one, simplify, you will get 6.1 into 10 power minus 6 order. So the angle of resolution is order of 10 power minus 6 radians. So option D is the right answer. So next question. So the periodic waves of intensities I1 and I2 pass through a region at same time at same direction. The sum of the maximum intensities and minimum intensities they are asking. So if there is a result of two intensities, there is a suppose the formula for the result of intensity of two periodic waves is result of intensity of two periodic waves at a point. Periodic waves at a point is given by I is equal to I1 plus I2 plus 2 square root of I1 I2 cos F. So F cos phi. Sorry, phi is the angle between intensities. So result is maximum when cos phi equal to 1. Right? Result is minimum when cos phi equal to -1. The sum of the maximum and minimum intensities are, this is the maximum. When is the maximum? And cos phi equal to 1. So I1 plus I2 plus 2 square root of I1 I2. So minimum will be I1 plus I2 minus 2 square root of I1 I2. So what is the sum of maximum and minimum? So I max plus I minimum will be 2 into I1 plus I2. So next question. In Young's double slit experiment of separation D between two slits, there is a Young's double slit experiment is there. The separation of between two slits as given. Okay. The Young double slit experiment, separation of two slit experiment between slits is 2 mm. And the wavelength of light used is lambda is equal to 5896 angstroms. And D is the distance between screen and slits. Okay. It is 100 centimeters. It is the distance between screen and slits. This is a Young double slit experiment. Okay. So there is a distance between. It is found that angular width of fringes is. It is found that angular width of fringes is equal to 0.2 degree. To increase the fringe angular width to 2, suppose to increase, they are asking to increase, suppose increase width of fringe from 0.2 degree to 0.21 degree with same we have to make the same with same lambda and d. We have to make it as same with same lambda and d. The separation of between slits needs to be changed. So initially it is 2 mm, na separation of distance between two slits is 2 mm. So how much we have to change that one so that it will become 0.21 degree by making the same of lambda. Lambda means wavelength and the separation between slit and the screen. So initially 0.2 degree. So angular width is actually, so before going to this one, I will. So what is angular width? Angular width theta is equal to lambda by d. So initially it is 0.2 degree, it is lambda by 2 mm. So we have to convert into ratio, but so anyway we are so using, so suppose here 0.21 degree divided by 0.2 is the same as if you convert into radian also, because ratio will cancel out. So now we want 0.21 degree with same lambda. We have to change the d, we don't know, that will be some d. Okay, so now if you divide the both, 0.2 divided by 0.21 is equal to d by 2, right? So 0.21, so it is d. How do you find out the d now? D is equal to 0.4 divided by now 0.2. So if you divide the both, 0.2 lambda will be 0.2 into 2, right? From here lambda will be 0.2 into 2. So if you substitute lambda here, d will be 0.2 into 2 divided by 0.21. So it will be 1.9 mm. So option B is the right answer. Next question. So in Young's double slit experiment, the intensity of light at a point on the screen where path difference is lambda. So there is a Young's double slit experiment. The intensity of a light on a screen, path difference, they are given the path difference. Path difference lambda is k. They are given. The intensity of light on the where the path difference is lambda, the intensity is k. Path, this is the path difference, lambda, path difference, lambda. Intensity is the lambda being the wavelength of light used. Okay. The intensity of point at a point where path difference is lambda by 4. What is the intensity that they are asking? So for lambda path difference, the phase difference will be, this is the path difference. Phase difference will be 2 pi radian. So lambda by 4, phase difference will be pi by 2 radian. So as k equal to 4 I naught, so intensity at given point where path difference is lambda 5 by 4, where k is equal to 4 I naught. So intensity at given point where path difference is lambda by 4. So now the intensity is, so now the path difference, and k dash is equal to 4 I naught cos square pi by 4. It will be 2 I naught. 2 I naught is k by 2. So when the path difference is lambda by 4, so it will become new intensity will be k by 2. So option C is the right answer. So next question. In Young's double slit experiment, the slits are apart. There are slits apart. D is equal to 2 mm. A part are illuminated by photons of two wavelengths. There are two wavelength photons, 12,000 angstroms and 10,000 angstroms. At what minimum distance from the common central bright fringe on the screen? 2 meter from the slit. So 2 meter from the slit. At what minimum distance from the common side is 2 meter from the slit? Will a fringe from one interface pattern coincide with a bright fringe from another? They're asking one coincide with a bright fringe from the another. So there is a slit here. There is two sources, S1, S2. These are apart from 2 mm. So this is at a 2 meter distance. So we know y is equal to so they are asking what they are at what minimum distance from the center common bright fringe. Center from the bright fringe on the screen from the slit will bright fringe from one interference pattern coincide with bright fringe from another. So you know so the fringe spacing is in the so in end double slit experiment, the condition for bright fringes to coincide is based on least common multiply principle. Okay, so in Young's double split double slit experiment, so in end double slit experiment, the condition for bright fringes to coincide is based on the least common principle. Least common principle of fringe spaces corresponding to the two wavelengths of fringe spaces corresponding to the two wavelengths. So the given if the spring spacing is x and the wavelength is lambda, x is equal to lambda d by small d. So they are given d as 2 mm. This so capital D as 2 meter, small d as 2 mm. So it will 2 into 10 power minus 3 meter. So lambda 1 is 12,000 angstroms. Lambda 2 is 10,000 angstroms. So now if we use this formula for lambda 1, x1 will be lambda 1 d by small d. So if we substitute 12,000 into 10 power minus 10 into 2 divided by 2 into 10 power minus 3. So it will be 1.2 centimeter. Lambda 2, x2 will be lambda 2 d by small d. It will be 10 power 4 into 10 power minus 10 into 2 divided by 2 into 10 power minus 3. So it will be, so it will be 1 centimeter, right? So here 10 power 6, 2 cancel, 12 into, here it is 0.1 centimeter, 0.12 centimeter. It will be like, see, if you cancel 2, then it will be 12,000, 10 power 6, 10 power minus 12 into 10 power minus 4 meter. So it will be 12 into 10 power minus 2 centimeter, 1 meter. So it will be 0.12 centimeter. Here also it is 0.1 centimeter. So from the bright fringes will coincide at the smallest distance where the integer multiply of x1 is equal to the integer multiply of x2. So the L is equal to n1 x1 is equal to n2 x2. So n1 by n2 will be x2 by x1. So it will be 0.1 divided by 0.12. So it will be 5 by 6. So n1 will be 5 and n2 will be 6. So L is equal to this. This is the what we want, right? Let the position of coinciding fringe will be L is equal to n1 x1. So 5 into 0.12 centimeter. So 5 into 1.2 millimeter. So it will be 6 millimeter. L is equal to. So option A is the right answer. Eighth question. In an N double slit experiment, the distance between the slits and the screen is doubled. Okay. In N double slit experiment, the distance between the slits and screen are doubled. The separation between slits is reduced to half. The fringe width will be, the fringe width is divided as lambda beta equal lambda d by d. So new d dash is 2d and this will be d by 2. So new beta dash will be lambda d dash by small d dash. So if you substitute, it is 2d and it is d by 2. So it will be 4 into lambda d by small d. So it will be 4 beta. So beta dash. It is becomes 4 times. Option C is the right answer. So next question. In Young's double slit experiment carried out with the light wave of lambda is equal to 500 angstroms. Distance between the slits is 0.2 mm. Screen at a distance from 200 centimeter from the slits. The central maximum is at x equal to 0. The third maximum taking the central maximum as 0th maximum will be at x equal to. So x equal to it will be we have to take lambda d by small d. And 0 then it is the third. So n equal to 3. 5000 angstroms. So 10 power minus 10 into divided into 2. 200 centimeters is divided into 2 meter divided by 0.2 into 10 power minus 3. So if you do the calculation, you will get 1.5 into 10 power minus 2 meter. So it will be 1.5 centimeter. So if yellow light is emitted, so next question, if yellow light is emitted by the sodium lamp in Young double slit experiment is replaced by monochromatic blue light of the same intensity. So actually, what will happen? Fringe with increase or remains unchanged. Beta equal to lambda d by small d. Lambda blue is less than lambda yellow. So that's why beta fringe width will be more for less for blue. So now it is a blue light emitting instead of yellow. So it is decreased. Lambda is decreased, so beta is also decreased. So option A is the right answer. It will decrease. Colors appear on the thin slope film and on slope bubbles are due to phenomena of. we know that the colors for which the condition for a constructive interference is satisfied are observed in a given region of film. Actually, here the path difference between light waves reaching the eye changes when the position of eye is changed. Therefore, the colors appear a thin soap film and soap bubbles due to phenomena of interference. These are due to the interference. Option C. So coming to the next question. In Young's experiment, two coherent sources are placed at 0.9 mm. Okay. So two coherent sources are placed at 0.9 mm. And fringe is observed 1 meter away if it is produces a second dark fringe at a distance 1 mm from the central fringe. The wavelength of the monochromatic light. So for the dark fringe, x is equal to 2n minus 1 into lambda d by small d, 2d. So lambda is equal to 2xd divided by 2n minus 1 into d. So n equal to, they had given, it is the second dark fringe, n equal to 2, we have to substitute. X and d they had given. So what is x? 1 mm. So 2 into 10 power minus 3. D we had given 0.9 mm, 0.9 into 10 power minus 3 divided by 2 into 2 minus 1 into d. D is small d. Small d will be 1. Here it is the capital D. It will be 1. 1 meter away. Capital D is 1 meter away. So D is equal to 1 meter. Small d is equal to 0.9 into 10 power minus 3. So if you substitute the values, you will get lambda equal to 0. into 10 power minus 6 meter. 6 into 10 power 5 minus centimeter. So option D is the right answer. So next question, 13th question. So Young's double slit experiment is performed with a green light of wavelengths of lambda blue will be 4360 angstroms. Lambda green will be 5460 angstroms. If x is the distance from fourth maxima, so actually x is equal to n into lambda capital D by T is proportional to lambda. If it is the fourth maxima, so x is directly proportional to lambda. So x green should be greater than x blue. Fringes with LED lights are thicker than of green light. So here, which one is the right answer? Option C. So x blue should be less than x green. So option C is the right answer. In Young's double slit experiment, the fringe width is found to be 0.4 mm. Okay, the whole apparatus, if the whole apparatus is immersed in a water refractive index 4/3 without disturbing the geometrical arrangement, the new fringe width will be. So there is a relation, new fringe width with whole fringe width. There is division with refractive index. So 0.4 divided by 4/3. It will be 0.3 mm. Option A. 15th question. Assume that a light of wavelength 600 nanometer is coming from a star. The limit resolution of telescope whose objective has diameter 2 meter. So wavelength given is 600 nanometer. So it will be 600 into 10 power minus 9 meter. The limit of resolution of diameter. telescope objective of diameter d is equal to 2 meter. So the limit of resolution of telescope will be limit of resolution of telescope will be theta equal to 1.22 lambda by d is equal to 1.22 into 600 into 10 power minus 9 divided by 2. So it will be 3.66 into 10 power minus 7 radians. So next question. A unpolarized light is incident from air on the plane surface of material refractive index mu. At what particular angle of incidence I it is found to be reflected and refracted rays are perpendicular to each other. Okay. There is incident ray. Okay. There is incident ray. There is a refracted ray and there is a reflected ray. This is the plane reflected ray. This is refracted ray. Refracted ray. This is incident. This is refractive index mu. When it will be 90 degrees, they are asking. So when it will be 90 degrees, tan I is equal to mu. Tan I is equal to mu when I is the Brewster angle. So I is equal to tan inverse of 1 by mu. Going to the next question. Two Polaroids P1 and P2 are placed with their axis perpendicular to each other. Okay. So unpolarized light I0 is incident on P1 and a third polarized P3 is kept in between P1 and P2. The intensity transmitted through P2 will be. So there is P1 and P2. There is intensity I0 transmitted I1. So suppose now P3, some P3 came into picture. So in between P1 and P2. Suppose it is I1, now it is I2 here and it is I3 after transfer. The intensity transmitted through P2 will be I3 will be they are asking. So according to Malus law, so it is at in between. So it is at 45 degree, right? So according to Malus law, I is equal to I0 square cos square theta. So theta equal to 45 degrees. So cos square 45 I0. It will be I0 by so they are asking the intensity I2, the intensity of transmitted light through P2. So it will be I1 will be I0 by 2. Okay, I1 will be I0 by 2. Again, I2 will be I0 by 4. I3 will be I0 by 8. So they are asking I2. So passing through the P2. So I2 will be I0 by 8. 4. So such that the maximum angle makes an angle 45 degrees with P1. It is the making the P1 angle. So what is they are asking, what is the I3 pass through the P2? So I3 will be I naught by 8. So option B is the right answer. So next question. The ratio of resolving powers of an optical. The ratio of a resolving power on optical microscope of two wavelengths, lambda 1 is 4000 angstroms and lambda 2 is 6000 angstroms. So now, so resolving power of a microscope is, so they are asking resolving power, right? Resolving power of microscope is, formula for resolving power of a microscope optic is equal to 2 mu sin theta divided by lambda. So if we take it as R, so R is inversely proportional to lambda. So R1 by R2 is equal to lambda 2 by lambda 1. So lambda 2 is 6000 angstroms divided by 4000 angstroms. So is equal to 3 by 2. R1 by R2 is equal to 3 by 2. So option B is the right answer. In a diffraction pattern due to the single slit of width A, the first minimum is observed at an angle 30 degrees. When light of wavelength 5000 angstroms is incident on the slit, the first secondary maximum is observed at an angle of, okay. So diffraction, there is a single slit with a width A. The first minimum is observed at an angle 30 degrees when the light of wavelength is 5000 angstroms. So theta is equal to n lambda by A. Sin theta is equal to. So sin 30 degrees is equal to lambda by A. So sin 30 will be half. Then A, so lambda by A is, we know, half. The second maximum will be sin theta is equal to 3 lambda by 2A. So it will be 3 by 4. Then so theta is equal to sin inverse of 3 by 4. So option D is the right answer. Next question. For a parallel beam of monochromatic light of wavelength lambda and diffraction is produced by single slit whose width is A, and the wavelength of light whose width is of a wavelength of light, if D is the distance between screen and the slit, okay, so lambda wavelength, it is the lambda wavelength of monochromatic wavelength. So A is the distance between slit and whose single slit whose width is A of the wavelength light. D is the distance between screen and the slit, okay, screen and the slit. The width of the central maximum will be, okay, so there is a screen. The central maximum lies between the first minima on the both sides, okay. The central maximum lies between the first minimum on the both sides. The angular width D at central maximum 2 theta is equal to 2 lambda by b. D into 2 theta is equal to d into 2 theta equal to 2d theta is equal to theta is 2d lambda by a. So option, so linear width of the central maximum y is linear width of the central maximum y. Here it given as y is equal to 2d lambda by a. Okay, so option D is the right answer. Next question, 21st question. At first minimum adjacent to the central maximum of a single slit diffraction pattern, the phase difference between Huygens wavelet from the edge of the slit and the wavelet from the midpoint of the slit. So they are asking, there is a slit, there is distance d, point O. From here there is P A. Perpendicular B and capital M. So this angle is phi and this is angle is also phi. So now at first minimum distance from the central maximum slit, the phase difference between Huygens wavelet from the edge of the slit and the wavelet from the midpoint of the slit. So it is equal to, so phase difference will be, so the first minimum is at a P, right? The first minimum is at P. At this point, the first minimum will happen. So AP minus VP is equal to lambda. So AP minus MP will be lambda by 2. So that the phase difference phi is equal to 2 pi by lambda into lambda by 2. So it will be pi radian. So option B is the right answer. Interference was observed in the an interference chamber. Interference is observed in the interference chamber where air is present. Now the chamber is evacuated. Okay. And if the same light is used, a careful observer will see. Interference was observed in the interference chamber where air was present. Now the chamber is evacuated. And if the same light is used, the careful observer will see. Actually, in vacuum, lambda increases very slightly compared to that of in the air, as beta is proportional to lambda. Therefore, the width of the therefore width of interference fringe increases slightly. So next question. So a beam of a light lambda is equal to 600 nanometer from a distant source falls on a single slit 1 mm wide. So there is a distance source of 1 mm wide. It is 10 power minus 3 meter. It will be 600 into 10 power minus 9 meter. And the resulting diffraction pattern is observed on screen 2 meter away. And the resulting diffraction observed on a screen is D is equal to 2 meter away. The distance between the first dark fringes on either side of the central bright fringe the distance between first dark fringes on the either side of the central bright fringe will be. So width of the central bright fringe is equal to is equal to 2 beta. It will be 2 beta is equal to 2 lambda d by small d. 2 into 600 to 10 power minus 6 into 2 divided by 10 power minus 3. So 2.4 into 10 power minus 3 meter. So it will be 2.4 into millimeter. So 24. Next question. A parallel beam of fast moving electrons is incident normally on narrow slit. A fluorescent screen is placed at a large distance from the slit. If the speed of electrons is increased, which of the following statements is correct? The angular width of central maximum of diffraction pattern will increase, or it will decrease, or it will be unaffected, but diffraction pattern is not observed on the screen in case of electrons. So there is screen here. There are two sources S1 and S2. It's a middle point. So there is a, this is D, this is Y. So angular width is Y by D, right? Theta is equal to, this is theta, suppose theta is equal to Y by D. So it is N lambda D by small d. So Y is equal to D lambda by small d. So theta is equal to lambda by d. So theta, so the angular width of refraction will increase or decrease or depend upon the frequency increases, lambda decreases and theta decreases. Frequency increases, lambda decreases, so theta. Frequency increases, so lambda decreases. So lambda decreases means theta will also decrease. Hence the increase in the speed of electrons, angular width of central maximum decreases. So option B is the right answer. Next question. So a parallel beam of light wavelength lambda incident normally on a narrow slit and diffraction patterns is formed on a screen placed perpendicular to the direction of incident beam. Okay. Now at second minimum of diffraction pattern, the phase difference between two rays coming from the two edges of the slit. So the conditions, what are the conditions for diffraction minimum? Conditions for diffraction minima are path difference should be n lambda and phase difference should be 2 pi to n pi. So n lambda is equal to, they are giving it is 2 lambda. So n is equal to 2. So phase difference will be 4 pi. To n pi will be 4 pi. So it will be n is equal to 2. So the phase difference between will become 4 pi. So option D is the right answer. A paper with a 2 mark have separation D, okay, held a normal line of sight of an observer at a distance D is equal is 50 meter. The diameter of eye lens as observed is 2 mm. Okay. So what is the following is the least value of d, small d, so that we can see, so that the marks can be seen as separate. The mean wavelength of visibility light is 5000 angstroms. So angular limit of resolution of eye is lambda is equals to theta is equal to lambda by d. D is the diameter of eye lens. So y is the minimum separation between the 2 points at a distance d from the eye. So theta is equal to y by capital D. So if you equate both, y is equal to lambda capital D by small d. So all of everything you know. So 5 into 10 power minus 7 meter. D is 50 meter into 50 divided by small d is 2 mm, 2 into 10 power minus 3. So y is equal to, it will be 12.5 into 10 power minus 3 meter. 1 meter will be 100 centimeters, so 1.25 centimeter. Next one. 27. In a fresh bell biprism, in a Fresnel biprism experiment, two position of lens or separation slits are 16 centimeters and 9 centimeters. What will be the actual distance of separation? So separation of slits R1 is equal to 16 centimeters. They had given R2. This is the first bill. Okay, experiment. So what is the actual distance separation will given by square root of geometric mean of 2. Actual distance of separation is equal to square root of R1 R2. It will be square root of 16 into 9. It will be 12 centimeter. Next question. A parallel beam of monochromatic wave 5000 angstroms incident single narrow width of d is equal to 0.001 mm. Okay. So they are asking light is focused by a convex lens, screen placed in a focal plane. The first minimum will be formed at an angle of diffraction. So angle of diffraction, first minimum is sin theta equal to L lambda. So it will be, n should be lambda. So sin theta is equal to lambda n lambda by A. A sin theta is equal to n lambda. So sin theta is equal to lambda by A. So it will be 5000 into 10 power minus 10 meter divided by 10 power minus 3 into 10 power minus 3 meter. So it will be 0.5. So sin theta is 0.5. It means theta is equal to 30 degrees. 29th question. Which of the following phenomena is not common used to sound and light waves? So sound waves cannot be polarized, they are longitudinal. Light waves can be polarized, they are transverse. The polarization of light is restriction of the vibration of light in a particular direction perpendicular to the direction of wave motion. Light is an electromagnetic wave and the transfer wave in nature. So option D, polarization of light is restricting the vibration of light in a particular direction. This is not common. So option D is the right answer. So 30th question. The ratio of the intensity is given as 4:1. Okay. I1 by I2, the ratio of the intensities is 4:1. So ratio of the intensity is proportional to is W1, W2 are the widths of the two slits from the intensities and A and B are amplitude. Then it will be A square by B square is equal to W1 by W2. Both are widths. So they are given A by B is equal to 2. So It is 2:1. So option A. The ratio of the amplitudes A is to B is 2:1. So 31st question. Interference is possible in wave phenomena shown by both light waves and sound waves. So this is a simple question. So option C is the right answer. 32nd question. Which of the following phenomena is not explained by Huygens construction of wavefront? Which of the following phenomena is not refraction, reflection, diffraction, or origin of spectra? So he explained everything first three: reflection, reflection, and diffraction. But the origin of spectrum he does not explain. The Huygens construction of wavefront does not imply the origin of spectrum, which is explained by the quantum theory. So Huygens construct can explain all these three, but origin of spectrum actually explained by the quantum theory only. So in an Young's double slit experiment, if the separation between the coherent sources is halved, okay, and the distance between screen and coherent sources is doubled, then the fringe width becomes. So fringe width we already know. So they are telling that d dash become new d, small d small dash become d by 2. But we know what is a fringe width: lambda capital D by small d. So new one is lambda d dash by d dash. It will be lambda 2d divided by d by 2. It will be 4 times of previous one, new one. So 4 times, option B. In a double slit experiment, when the light of wavelength 400 nanometer was used, the angular width of the first minimum formed on the screen placed 1 meter away was found to be 0.2 degree. What will be the angular width of first minima if the entire experimental apparatus is immersed in water? So first, for a double slit experiment, uh, the angular fringe width theta naught is equal to beta by d. Okay, angular fringe width in water will be theta w is equal to beta by mu d. It will be theta naught by mu. So 0.2 degree divided by 4 by 3. It will be 0.15 degree. Option B is the right answer. So next question. In a double slit experiment, if there is no initial phase difference between the light from the two slits and a point screen corresponding to the fifth minimum path difference. So in a double slit experiment, what happened if there is no initial phase difference between two light from the two slits? There is no point. There is a point on the screen corresponding to the fifth minimum has a path difference. So path difference for the destructive interference is in a double slit experiment. Path difference for destructive interference. In double slit experiment, delta xn is equal to 2n minus 1 divided by 2 into lambda, when n is the integer. So fifth one will be delta x5 will be, when put n equal to 5, it will be 9 lambda by 2. So option D is the right answer. Okay. So we completed the chapter here. We have done all the questions. Thank you. We will meet in next session.